Okay, so we're going to do some notes. This is the introduction to what's called the Pythagorean Theorem. Okay, and this is going to have to do with triangles. So basically what we're going to do, reminders of some things about triangles. So first of all, in all triangles, the three angles in the triangle add to 180 degrees. Okay, but in a right triangle, this is a triangle with a 90-degree angle. Now, specifically, the Pythagorean theorem is only for right triangles. So let's look at a right triangle here. So here's an example. Here's a right triangle. And in a right triangle, cat. Sorry about that. So in a right triangle, you have what are called legs, which are the two sides next to the right angle. So the legs are the two shorter sides in general. Okay, and then there is another side which is across from the right angle, and that's going to be the longest side. And in a right triangle, that's called the hypotenuse. Okay, so then the hypotenuse, no, Baxter. The hypotenuse, this is the longest side of the right triangle. Baxter, Maggie, can you take the cut away, please? Can you take Baxter away, please? All right, so anyway, and this one is always across from the 90-degree angle. Okay, so what the Pythagorean theorem says, and this is, again, this only works for right triangles. So in the Pythagorean theorem, okay, and in these right triangles, what it basically says is that if you square the side on the leg, one leg, and you square the side on the other leg, it equals the hypotenuse squared. Okay, and often these legs are denoted A and B. Okay, so that the formula becomes A squared plus B squared equals, and then the hypotenuse is called C, so equals C squared. Okay? So, in general, that means that you're going to square both sides, and it's going to equal the hypotenuse squared. Okay, now before we do that, before we look at actual examples of this, we need to kind of go back and remind ourselves of some things, some square root things, and some rational and irrational number things. Some terms that would have been more what you were working on last year. So first of all, just squaring and square roots. Okay, so just a reminder that if we square something like 3 squared, that's 3 times 3. Okay, and basically squaring means you multiply the base by itself twice. Okay, and if we do the reverse, so if we take the square root of something like square root of 9, it becomes 3 and also negative 3. Now, all we're going to care about for this is, for the most part, this 3, because it's positive. And when you're doing lengths of triangles, they're always going to be positive. So the other thing we want to be reminded of from basically, again, last year, so in 7th grade rather than 8th grade, is rational and irrational numbers. So rational numbers are anything, all numbers that can be written as a fraction. Okay, but what we're going to be dealing with here, so like this is all repeating and terminating decimals. So any number like, 7/9, which is 0.77 repeating, 10/2, which is 5. Those are rational numbers. And so we will be using rational numbers, 0.6, which is 2/3, which is 0.6 repeating. All of those numbers are rational. We'll be using rational numbers when we do the Pythagorean theorem, but we'll also be using something called an irrational number. So this is a number that can't be written as a fraction. Okay, at least not with integer coefficients. With integer numerator and denominator, basically. Okay, and why is this important? Because when we do the Pythagorean theorem, many numbers are going to be like this. So, for example, pi is an irrational number. But also things like square root of 2, square root of 5, square root of 19. And we're going to be using these types of numbers. And so basically, just leave them as a square root rather than trying to find a decimal. Because these are non-terminating and non-repeating decimals. Okay, so why is that important? Because now when we do the Pythagorean theorem with triangles, we're going to have a lot of numbers that actually end up being irrational. So let's give an example of the Pythagorean theorem using a right triangle. So the first example is just a regular old right triangle. And it's a right triangle because we'll see that it has a right angle here. Okay. And one side is 3, one of the legs. And the other leg is 5. And we don't know the hypotenuse. Okay. So hypotenuse, or C, we don't know. Okay. So we know that one side is 3 and the other side is 5. So what we will do now is set up that formula. So the Pythagorean theorem says a squared plus b squared equals c squared. Okay, now you just choose one to be a and one to be b. It doesn't matter which one. So I'm going to make this a and this b. Okay, so we have 3 squared plus 5 squared equals, and now remember we don't know what c is, so equals c squared. 3 squared is 3 times 3, which is 9. 5 squared is 5 times 5, which is 25. And that equals c squared. Now, 9 and 25 is 34. But that equals c squared. So remember, the opposite of squaring, we want to find c, not c squared. So we'll do the opposite of squaring. And the opposite of squaring is square root. Okay, but when we do that, we have to take the square root of both sides. So what we're going to do is take the square root of this side and the square root of 34. Now, square root of 34 is a non-repeating, non-terminating decimal, so we'll just leave it as square root of 34. Square root of c squared is just c, because the square root and squaring pieces cancel out. So our answer is square root of 34. So this side is the square root of 34. Okay, and we don't worry about the negative because, again, a length will always be positive. Okay, so you don't have to worry about the negative. So let's do a couple more examples. So example 2 here. So again, we'll have a right triangle. We'll draw it the other direction. Okay, so this time we have 4 and 6. Okay, and again, we don't know that third side, that hypotenuse, so we're just going to call it C. And this time we'll do the exact same thing we did before, which is 4 squared plus 6 squared equals C squared. Okay, 4 squared is 16. 6 squared is 6 times 6, which is 36. And 16 plus 36 is 52. So again, like we did before, we'll take the square root of both sides. And so the square root of 52 equals C. Now, if you want to put it on your calculator and you want to approximate it, you can. If you want to round, for example, so if I wanted to round to the nearest tenth or something like that, you could put it on a calculator, and square root of 52 is around 7.2. Don't worry too much about that, although if IXL asks you to round, then that's how you would do it. You would just put it on a calculator, take the square root, and round it to the nearest whatever you're asked to do. But square root of 52 would be just fine, as long as you're understanding how to do the formula. Okay, so let's do a couple of examples that are, you're given a different side. So, for example, if you're given the hypotenuse. So, let's do an example if we're given the hypotenuse. So there's a triangle, and here's your right angle, so it is a triangle. But we know this, and we actually know the hypotenuse this time. What we don't know is this side over here. We'll call it A. Okay? So we know the formula again is A squared plus, and then B squared. But B has to be the leg. So remember, it's leg squared plus leg squared equals, in this case, hypotenuse squared. Okay? But we don't know A squared. 2 squared is 4. And hypotenuse squared is 7 squared is 49. So now what you're going to have to do here is you're going to have to subtract the 4 from both sides like you would in solving a regular equation. So that goes away. So now we have A squared equals 49 minus 4 is 45. Okay, and then again, we'll just take the square root. So in this case, A is the square root of 45. Okay, so this side, no, Baxter, no, is the square root of 45. Okay, let's do one more example where we have, we are given the hypotenuse, so you can kind of see how that works. So example 4. Okay, so there's your right angle, and let's say this is 7, and this is 10. Okay, whoops, I'm sorry, no, that's not 10. This is 10. Okay, let's say that. So that's 10. Okay, so now, and we don't know that side, which is A. Or B, it doesn't really matter. I'm just avoiding B because it looks like a 6. So in this case, now I'm going to set up, remember I have that A squared plus B squared equals C squared. And I'm going to plug in, I know my A squared, I know my 7 squared, and I know that C squared is 10 squared. So again, I'm going to do A squared, 7 times 7 is 49, and 10 times 10 is 100. And then I would subtract the 49, and I'd get A squared equals, in this case, 51. And then I take the square root of that. So then A is square root of 51. Now, you could, if you want, kind of take, sorry, that's supposed to look like a 1. You could take a kind of shortcut if you realized you had the hypotenuse and just kind of subtract and do 10 squared minus 7 squared equals a squared. Like that, you'd get the same answer. So it would be 100 minus 49 equals a squared, and then 51 equals a squared. And you still end up with that square root of 51. Okay? One last thing in determining if something is a right triangle. So this theorem works for all right triangles. And the reverse is also true. So if a triangle well, here, let's say it a different way. If the Pythagorean theorem is true for a triangle, then it has to be a right triangle. Okay, so let's do one last example here, and we're on what, example 6, I think, or 5, excuse me. I think we're on example 5. Is that right? Yep. So Baxter, you're not helping, bud. He's been doing this the entire time. So last example. So is this a right triangle? And we're going to do 2 examples of this. Okay, so for example 5, let's say that's 12, let's say that's 13. And then this other triangle, that's, let's say 8, let's say 9, and let's say 10. Okay, so let's try this one out. So if I say this is my A, this is my B, and this is my C, all that matters is that 13 is the C. Okay, so I would do 5 squared plus 12 squared equals 13 squared. Okay, 5 squared is 25, 12 squared is 144, and 13 squared is 169. So 25 plus 144 is 169. So 169 equals 169. So yes, this is a right triangle. Okay, we could try the same thing with this one here. Okay, so 8 squared is 64, 9 squared is 81, and 10 squared is 100. And 64 plus 81 is, what, 145? And that does not equal 100, so no, this is not a right triangle. Okay, and that is it for Introduction to Pythagorean Theorem. There are some problems on IXL that are going to be your assignment for the rest of today as well as the next available class period. Have a great day. Bye.